At this point, we've spent a lot of time looking at how to solve quadratic equations. One of the most useful methods is called the quadratic formula. To recap what that is, remember that it's going to be the opposite of b plus or minus the square root of b squared minus 4ac, and then we take that and divide it all by 2a. So this equation, and it's x equal because it's solving for it, this formula will always solve a quadratic equation. Now, in some cases, as you look on your note sheet here, the two answers that you end up getting are going to be perfectly regular real numbers. Sometimes they're whole numbers, sometimes they're going to be with square roots in them. Sometimes when you're going to get an answer that is exactly the same. In this case here, where I have 2 plus or minus, well, the square root of 0 is 0. So when you add a 0 and subtract a 0, it doesn't change the number. So you technically get the same answer twice. And then in even other cases, you've had situations where you have a negative square root, which we know is called an imaginary number, which is why we write the I on the outside. So we're going to be able to predict when we're going to get this type of a situation versus this type using something called the discriminant. So the discriminant, very simply, is just the name that we're going to give to the expression that appears under the square root in the quadratic formula. So if we look at the quadratic formula, the expression in the square root is the b squared minus 4ac. And so the b squared minus 4ac is what we call our discriminant. And finding the value of this is actually going to give you a prediction of what type of answer you're going to expect to get. So for example, we go into these examples. Our first problem, the discriminant, is everything inside the square root. So it's this 6 squared minus 4 times 1 times 5. And when we simplify that, we end up getting a positive 16. So whenever your discriminant is going to be a positive number, anything greater than 0, you're always going to get two values. Now, they may not always be whole numbers like this, and part 2 of this video discusses that. But whenever b squared minus 4ac is greater than 0, you will always get two values, two real numbers. Now, in the case where your discriminant, so in this example, the discriminant is negative 2 squared minus 4 times 1 times 1, this time I end up getting a discriminant, or the square root value is 0. And in that situation, I still get technically two answers, but the two answers are exactly the same. And so in any situation where b squared minus 4ac is going to equal 0 specifically, you're going to get one repeated solution. So it's technically repeated, but you only get really one unique number. And in the final situation, when your discriminant turns out to be a negative number, so something less than 0, well then, by definition, we can't have that as a real number. We would then call it the imaginary number, as we have here. So in the situation where b squared minus 4ac is less than 0, we're going to say this yields two imaginary / complex. The two words are interchangeable here, solutions. Okay? So this is really the main chunk of the lesson, and so finding out the nature of your answers is going to help immensely, especially when we start graphing soon. So let's turn to the back and look at 3 examples. So the first one gives us x squared minus 7x minus 22. Now all I want to do here is not solve it, I just simply want to use the discriminant to determine the nature of the solutions, what type of solutions I'm going to have. So I'm going to use the square root inside the square root, which would be b squared minus 4ac. Now, if you don't know your a, b, and c, it might be helpful on the side to list that. So my a here is going to be 1, because there's nothing in front of the x squared. My b is negative 7, and my c is negative 22. So when I plug everything in here, my b squared is going to give me negative 7 squared minus 4, a is 1, c is negative 22. Negative 7 squared is 49. Now because I have a negative here and a negative here, that's going to be a positive number, and I'm going to multiply 4 times 22, which is going to give me 88. And at this point, you know you're going to end up with a positive number. So if you end up with 137 here, what that's going to mean is that you're going to get 2 real solutions. Remember, real is just any type of number that doesn't have an I in it. In the second example, we have our A, our B, and our C that we need to figure out. A would be 3, B is going to be 6, and C is going to be 72. Once again, let's plug that into b squared minus 4ac and see what we get. So b squared is going to be 6 squared, 4, and then times a is 3, c is 72. 6 squared is going to give me 36, and there's only one negative sign here, so that negative will just stay there. 4 times 3 times 72, I end up with a value of 864. Now, technically you could subtract that, but you should at this point see that this is not going to give me a positive value. It's going to give me a negative. And so technically it's going to end up looking like negative 828 is our answer. So what that tells me is my solution when I solve it with the quadratic formula is going to give me 2 imaginary / complex solutions. One thing to keep in mind with these examples is notice how I still have it set equal to 0, as if I was going to use the quadratic formula. So you still need to set the equation equal to 0, and so example C shows you that you need to actually be aware of that. The fact that I have the 84 on the right-hand side tells me that I need to move it over before I solve using the discriminant. So if I subtract 84 from both sides, the quadratic I'm working with is x squared plus 5x minus 84, and that's equal to 0. So now I can use the discriminant. And so again, it's b squared minus 4ac. B is 5, so 5 squared, minus 4. A is 1. C is negative 84. And there's my discriminant. Now I just have to do a little bit of work. So I end up with 25, a negative and a negative. Once again, that's going to make this a positive number here. And so 4 times 84 times 1 is 336, and when I add those together, that gives me 361. Since it's a positive number, that means just like the first example, I'm going to have 2 real solutions here. With that being said, at this point in the video, I want you to take a pause. So we're going to stop where we're at, and on page 9 of your quadratic packet, it's going to look something like this, where it says home run at the top. What I'm going to ask you to do is complete the 10 problems listed there. In the first column, let me put the worksheet on. In the first column, you're going to find what the discriminant is, just like I did. And then your number of solutions, once you know your discriminant, you'll know what your number of solutions is going to be here, or how the solutions are going to be. Are they going to be real? Are they going to be imaginary or complex? Or is it just going to be one repeated solution? Once you're finished these problems, check with someone in the class if you're working on it in class. And when you are finished, you may resume this video for the second part of the lesson. And so at this point now, we should be ready to go with part 2. Let's take a look at part 2. So, in addition, you can use the discriminant to decide if the quadratic equation can be factored. So, it first off must be positive. So, if the discriminant is positive, and here's the kick. Not only does it need to be positive, but the number needs to be a perfect square. So if the discriminant is positive and a perfect square, then, perfect square, then it is factorable. Which means you wouldn't have to use the quadratic formula, you could just use the snowflake or asterisk method or whatever method you've learned to factor with. So remember your perfect squares. I wrote the first couple up here for you. After 81 would be 100, and then 121, 144, and so on. So you can use the discriminant to determine whether it can be factored. So just like we did in the examples earlier in this video, we're going to now use the discriminant to figure out if this will be factorable. So the first one here, I have 4x squared minus 16x minus 32. So once again, the discriminant is just b squared minus 4ac. That means I have negative 16 squared minus 4 times negative 32. And so when solving this, I'm going to get 16 squared, which is 256. And then negative and a negative here, so that means this will be a positive. 4 times 4 times 32. That's 512. When I add those two numbers together, I'm going to get 768. So the question is, we know that this is going to give me two real answers by our discriminant. But will this give us a factorable problem here? And so what we need to look at is, in the calculator, it's just as easy to do this. Just simply take the square root of 768. And so when I do that, I get 27.71. So what that tells me is that this would not be factorable. So the answer would be not factorable, which means I probably am going to use the quadratic formula if I had to solve this. The last example, like we had done earlier, we want to make sure that everything's on the same side. And so we're going to make sure that that 84 has been subtracted. And once again, set up for the discriminant here. So b squared is 5 squared minus 4 times 1 times negative 84. 5 squared is 25. You might remember this. This is actually the exact same problem we did in example C. So the number we should get is 361. Now, if we want to test this to see if this will be factorable, let's take our calculator out and take the square root of 361. When I do that, I get 19. So because the discriminant yields a whole number, that means 361 is a perfect square. So this problem actually would be factorable. What that tells me is problem A here, you would need to use the quadratic formula. Problem B, you could use the quadratic formula to solve it, or because we know it's factorable, you can use the snowflake method. So this is going to help save you time, especially when we begin graphing and looking a little bit more in detail when working with quadratic equations.